Hi everybody. Today we're going to do a quick tutorial of Maple to help you prepare for doing the Maple 1 assignment. So the first thing you want to do when you log into Maple is to create a new document. And so you're going to get this blank page showing up. And in most of the assignments that you're going to be doing on Maple, you'll eventually need to do some graphing. So a good habit to get into is to load all of the plots packages first. And the way to do that in Maple is to type in with parentheses plots. And when you hit enter, you'll see this whole list of different plotting applications that will be available to you. Now, these take up a lot of space written here, so another option you could do is you could put a colon after the with plots, and that just hides all of that stuff. That's totally optional. You can hide it or not, it doesn't matter. So we're going to need some of that stuff later on, but the first problem we're going to look at today, or the first several problems, are going to be some limits. Now, I tried to create some examples here that are pretty similar to what you'll see in your Maple 1 project that you have to do. So we're going to do the limit as x approaches 2 from the right-hand side of x divided by x squared plus x. So in order to do that on Maple, we just type in the word limit, and then we are going to type in that formula, which was x over x squared plus x. So I'm going to press x, and then to do division, we're just going to use that / key, and that automatically turns whatever you were working on into a fraction with your cursor now in the denominator. So down in that denominator, I want to type in x squared plus x. So I'm going to hit my x button, and to get a square on there, we're going to use the caret key on our keyboard, which is right above the number 6. So I'm going to do Shift 6, so I get up into that power, type in a square, and notice that your cursor is still up in that power, so we're going to need to hit the right arrow to get it back down to the level that we want it at to finish continuing to type plus x. Now, after you've typed in the function that you're trying to take the limit of, I'm going to click my right arrow once more so I get back to the main level, and then I need to tell Maple what I want to take the limit of what should x approach. So in this example, I want x to approach 2 from the right hand side. So to do that, I'm just going to do comma x equals 2. If you leave it like that, it's going to take the limit as you approach 2 from both sides. So if I want it from the right, then I'm going to need to do comma right, and then close the parentheses, hit enter, and there's our solution. Okay, so pretty simple. You can tell as we go through these examples today that Maple is very powerful. Just showing you the power that's available to you to do some of these problems. We won't do a whole lot with it in Calc 1, but you will be using Maple quite a bit as you progress through Calc 2 and so on. All right, let's try another limit example. This time I want the limit as x approaches pi from the left side of the function x squared cosecant x. So again, I'm going to type in the word limit, parentheses, and my function was x squared cosecant x. So I'm going to do x power square, hit your right arrow to get it back down to the level of the x, and then this is really, really important, and it's something that I mess up all the time on myself. Maple is very particular about requiring you to physically type in the multiplication that is implied between our x squared cosecant x. That's really x squared times cosecant x, right? So Maple requires you to put in that times symbol. And the way to do that is to use the asterisk key, which is right above the number 8. So I'm going to do Shift 8, and that asterisk actually shows up as that product, that dot. And then after that, we're going to type in the word cosecant. So notice something here. When I first type in CS, notice how the C and the S are italicized. But as soon as I type in the last C, it becomes unitalicized. That's the symbol that you're referencing an actual built-in function, in this case the cosecant function. All right, that's what you want. All right, if you don't see that happening, the program is going to assume that you're talking about just some really weird named variable. So again, notice without that last C, it's italicized. When I put that final C in there, it becomes unitalicized. And then this is also very important because it's a cosecant function. Maple requires that you wrap in parentheses whatever you want that input variable to be, and I want an X in there. So you have to write that X in there. If you don't, notice how everything is still italicized. So Maple is thinking that you have created some really weirdly named variable called CSCX, and it's just some letter, some variable, all right? Without those parentheses and that non-italicized version of cosecant, you're not going to be getting the actual cosecant function that you want. All right, so we've typed in our function. Now remember, on this problem we wanted the limit as I approach pi from the left-hand side. So I need to tell what x to approach. So I'm going to do comma x equals. Now again, this is also something very specialized in Maple. In order to access the actual numerical value of pi, you have to use a capital P I. And notice again how that turned from italicized to non-italicized. If you use lowercase pi, it changes to being non-italicized, but it doesn't recognize that that lowercase pi is actually supposed to be the number 3.14159, etc. It's thinking of that as just the symbol pi. I'll show you what that looks like in a minute. So I'm going to go back first and do capital PI, and we wanted this limit from the left side. So I'm going to do comma left, close the parentheses, hit enter, and we get infinity. Okay, so a couple of things. What if I change this left-hand limit to a right-hand limit? Now it's negative infinity. So think about that for a minute. If the left-hand limit was going to positive infinity and the right-hand limit was going to negative infinity, what should the two-sided limit be? Undefined, right? Because they're going in different directions. All right, so that limit doesn't exist. Let me show you what this looks like if we used a lowercase pi. Notice that it's not giving me a value, it's giving me symbols. All right, so if you want the numerical value of a limit using a pi, you have to have that capital in there. And we wanted it from the left side. So there was that infinity again. Okay? All right, next example is the limit as x approaches 7 of this big fraction, square root of x plus 2 minus 3, all over x minus 7. So let's start typing that in. So I want the limit of, now to get the square root symbol to show up, you're going to use the function sqrt. Again, notice how it became unitalicized. And then in parentheses, you're going to type what you want inside of that square root. So we wanted x plus 2. I'm going to close the parentheses on that. And then next to that square root function, we wanted to subtract 3. And then we wanted to divide all of that by x minus 7. So look what happens if I type my forward slash again to get divide. Notice that it's only dividing the 3, which is not what I want. I want that entire square root minus 3 to be in the numerator, not just the 3 to be in the numerator. So this is not giving me the function that I want. All right, so what we have to do is actually, I'm going to erase all of this and start fresh because I want parentheses around that entire numerator. So I want to put parentheses square root of x plus 2 minus 3, And then I'm going to close the parentheses around that entire expression before I hit my backward or my forward slash here, my divide. And now it's going to take all that stuff that we had in parentheses and leave it all in the top. Underneath that, I want x minus, whoops, it does that for some reason. I need to put my cursor back in the bottom and finish typing in my x minus 7 down there. Then I can go back up. So there's the correct function typed in. We wanted the limit of this whole expression as we approach 7 from both sides. So to finish, I'm going to type comma, x equals 7, close the parentheses, and then we get our answer. Okay, so progressively these limits are getting a little bit harder for us to do algebraically, and so it's nice that Maple can do them so quickly for us. All right, let's try one more limit. Notice again that this is another big fraction, and we want all of this stuff in the numerator to be divided by that h. So before I start typing in that 1 over h plus 3 fraction, I want to make sure that I have some parentheses in front of that. Okay, so we're going to type in the word limit, and then parentheses to start the limit, and then another parentheses to start the numerator. So I want 1 divided by h plus, there it goes again, go back down here, plus 3. Then I'm going to do my right arrow to get back to the top, minus 1 divided by 3, right arrow, close the parentheses around that numerator, and then I'm going to hit my divide and do h on the bottom, right arrow, comma, we want this limit as h approaches 0 from both sides. And there we get negative 1/9. Okay, so very easy to do limits, both-sided, one-sided limits on Maple. Okay. All right, so that should take care of question number 1. Let's move on to question number 2. This time around, we want to define the function f of x to be x squared sine of x, and then we're going to find its derivative function. So before I jump into that, notice right away that our function f of x is x squared times sine x. So make sure that when we type in that f of x function's rule, that you're putting in that times symbol in between the x squared and the sine x. So how do you define a function in Maple, and why would you want to? Well, it's nice to define a function in Maple so that you don't have to keep retyping the formula over and over again. So to define a function, what we do is we first give it a name, and I'm just going to call this function f. And then after that, to define it, you're going to hit colon equals. Okay, so that's how we define. And this is a function of, in this case, x. So I want to have my input variable be x. And in order to do that, or in order to tell it what the rule should be, we need to, sorry about that, we need to do the following, okay? Next thing you're going to do is type the subtraction button, followed by the greater than symbol. And as soon as you do that greater than symbol, you should see that turn into a little right arrow. Okay, one more time. Subtraction, greater than, and it turns into that arrow. Now after that arrow is when you're going to type in the actual rule, which for us was x squared sine x. Okay, so I need to do x squared, move my cursor down, and remember you have to type in that implied multiplication. So I'm going to do Shift 8 to get that little dot to show up. And then after this I wanted sine of x. So I'm going to do sine parentheses x. And now hit enter. And you can see that now Maple has stored in its memory that you have defined the function f to have as its rule x squared times sine x. Okay? So now let's say I wanted to figure out what the derivative of this function is. So all I have to do is, remember, we called this function f, so if I want its derivative, that would be f prime of x. So to type in f prime of x, you just hit F, and your prime key is going to be the apostrophe, and then parentheses x. Now notice it's really hard to see that little prime. It kind of gets absorbed into the little curl of the f, but it's there. If I hit enter, there you can see your derivative with that product rule applied. All right, so that takes care of excuse me, part A, defining your function and then finding its derivative. Now what I want to do is I want to make a plot. So I'm going to plot two things. I want to plot this original function f, and then I want to find the tangent line to that graph at pi over 4 and plot that on the same graph. Okay, now you could, on your own paper, take the derivative, plug in pi over 4 to find the slope at pi over 4. You could take pi over 4 and plug that into the original function f to find the y value at pi over 4, and then use our point slope form, y minus y1 equals m times x minus x1, to come up with that equation of that line, and then type that into Maple. But we don't need to do all that. We can make Maple do all of that work for us. So here's how we're going to do that. First of all, to do a plot, we just type in the word plot and then a parentheses. Now, if you're plotting more than one thing at a time, which we are, because we're going to plot f and the tangent line to f, you need to use a bracket to list all the things that you want to graph if it's more than one thing. So I want to graph f. Now I can't just type in f. I have to type in f of x. Whoops. F parentheses x. And then comma. Now I want to type in that tangent line. But I didn't write down what that is yet, right? We were going to make Maple figure it out. So remember that point slope form, y minus y1 equals m times x minus x1. I'm going to use that, all right? So if I were to solve that point slope form for y, that would require moving that y sub 1 over to the other side. And y sub 1 is just the value of the function at pi over 4. So here's how I could type that in. F parentheses capital Pi divided by 4. So that's the y1. That's the y value at pi over 4. And I want to add to that the slope at pi over 4. I want to multiply that, or I want to add to this m times x minus x1, right? So m in this problem is that slope. And how do you get a slope? You get it from a derivative. So I'm going to do f prime. Again, it's really hard to see that prime symbol, but it's right there after where that apostrophe is. Parentheses pi divided by 4. So there's the slope at pi over 4. And we need to multiply our m times x minus x1, right? Remember point slope form? So make sure that you type in that physical multiplication symbol. So shift 8 to get that little dot in there. And then in parentheses, I'm going to do x minus, and the x1 in this whole problem is that pi over 4. So capital Pi divided by 4, close the parentheses. So again, here's your y1 plus m times x minus x1. So this is just point slope form using the function f with the x value pi over 4. All right, so that's the second thing that I want to plot. So I'm going to close the brackets on those two things, the function f and its tangent line. And then in order to give some guidance here on what window I want, let's do comma, and let's look at this for x's from 0 to 1. So the way I would type that in is x equals 0 dot dot 1. Notice it's only 2 dots, not 3 dots. And if I close the parentheses and hit enter, we get our graph. So here's the x squared sine x function f, and here is the tangent line at pi over 4. Pi over 4 is right about here. Okay? All right, now a couple of optional things you can do on a graph. You certainly do not have to do these for me, but if you want to, you can add some grid lines to your graph. So to do that, after that x equals 0 dot dot 1, I could type comma grid lines, and that just adds in those grid lines, so it's a little easier to see. Another option, sometimes these graphs are a little thin, so you could make them a little bit thicker. So to do that, you could do comma, thickness, and I'm just going to set the thickness to 3. You can see that this just makes the curves a little bit bolder, a little bit stronger. And then you could also change their colors to whatever you want. So I could do comma, color, equals, and since there's 2 graphs, not 1, but more than 1, we need those brackets again. And let's let the original graph be black, and let that tangent line be red, bracket. And that just makes it a little bit more obvious which curve is which. All right, and then one other thing you could do, again, all of this is optional, is you could change the viewing window, not just specifying what x's to use, but also specifying what you want your y's to be. So for example, you could do comma, and we're going to kind of create what's like a viewing window on our graphing calculators. So we're going to use the command view, and we want it to equal bracket. And so for my x's, my x min, I'm going to let be 0, dot, dot, and let's let our x max be pi. So capital Pi, comma. After these, we're going to type in the y min and the y max that we want to use. So let's let our y min be -2, and let's go up to 5. Close the brackets. So these first set of numbers are the x min and x max, and these second set of numbers are the y min and the y max. And now if I hit enter, you can see that graph much shorter now because we have adjusted the window. All right, I don't really like that view, so I'm going to take that off, and let's just leave it how we had it before. Okay? All right, so that's part A and part B. All right, let's try one last example here. This time around, we're going to define the function g to be the function 3 cosine 2x minus x. So remember, to define a function, first you give it a name. So I'm going to call it g. And then to define something, you do colon equals, and then you type in the rule, which before I type in the rule, I have to tell it what input variable to use. So I have to use that x. So I'm going to do x, then hit your subtraction button, followed by the greater than symbol to get that little arrow to show up. And once I have that in there, then I can type in the rule that I want to use. So our rule is 3 cosine 2x. Be careful here. I'm going to do 3 times cosine parentheses 2x, and then minus an x on the side. Notice how I put that times symbol between the 3 and the cosine. So there's my g function defined. Now what I want to do is, now that I have this function in there, I'm going to use Maple to plot g, g prime, and g double prime all on the same set of axes using the interval -2 pi to 2 pi. Okay, so we're making a plot with multiple functions that we're graphing. So to do a plot, you type in the word plot, parentheses, and since we're graphing 3 different things, we need brackets. So bracket, g of x is my first function. Then I also want to graph the derivative, so g prime of x, using that apostrophe, and then comma, g double prime. Now to get the double prime, you don't use a quotation, you use the apostrophe key twice. So g apostrophe apostrophe and then of x. So there's my g of x, g prime of x, and g double prime of x. And I'm going to close the brackets off. Those are the three functions I want to graph. And then I want to graph this from x equals -2 times capital pi dot dot up to 2 times capital Pi pi. And let's see what that looks like. There you go. Okay, now there's a lot going on here, so it might be helpful to add some colors in here. So I could do, let me increase the thickness a little bit as well. So let's do thickness equals to 3, and for our colors, I'm going to do color equals bracket. Let's let the original function g be black. Let's let the first derivative be red, and let's let the second derivative be blue. Close the bracket, hit enter. And now you can see those a little bit more clearly. So here's the original g, the red is the first derivative, and the blue is the second derivative. All right, I think we did it. So a couple of things, when you're done, you have a couple of options. If you go under File, you can save this as a Maple file. Good thing to do. If you're ever doing your Maple assignment and you're having trouble and it's not giving you what you think you should have, you can always send me or email me your Maple file and I can try to figure out what might be going wrong. Maybe you forgot a time symbol somewhere or something like that. So that's always an option, is to save it as a Maple file. The other thing that I want to show you is that I do ask that when you turn in your completed Maple assignment, I would prefer that you print it off. So you just click on print and it's going to print everything that you typed in and all of the results that came up. So this whole screen would get printed off. Okay? All right, that should be it. If you have any questions, don't hesitate to reach out. Good luck.